basically in this problem of the week, there's a bunch of teachers in a room, and they sit down in a desk in an order, and somebody goes by and crosses off every other one, and then when they get to the end, they like come back and cross off every other one that's still in, and the last one wins. And you're supposed to basically, regardless, like the number of desks can change, and you have to be able to say like, based off the number of desks, which desk is gonna win. And so, for like I decided to make like a program that could solve this, and basically, it goes through and does the same thing that we do. So, it does like it has this thing called the host, which is the person going along. And so, say there are 3 teacher desks, so it arranges them like this. So in an order, in a list. So this is the position they're in. This is the teacher's number, like what desk they sat in. And so it starts, this is good, this one's bad. So it crosses, so the host starts at 2 and crosses them off. Now the new list looks like this. Position 1, there's one person. Position 2, there's another person, and they are number 3. The host is still here, and then after they delete, the host goes up by 1. So it goes up by 1. So now the host is all the way over 3. There's nobody here. So I take the length of this list, and if the length of the list is 1 above, if the host is 1 above the length of the list, then I know that I need to go to 1. So basically, then it goes down here and goes to 1 because this one's good, and it just skipped it. So now it's back up here and can cross this off, and then 3 wins, which is how it normally would go. And then so basically it was pretty easy to get it to like go every other, because it would delete 1, and then a new one would fill that place, and the whole list moves up, and then it just goes 1 down. And since the whole list moved up and it went 1 down, it's basically skipped a person. And then so the tricky part was getting it to loop back around. So that loops it back around for the odds. But when there's an even number, with 4, a similar thing happens. So after the first step, you have 1, 3, and 4 left, in positions 1, 2, and 3. And the host just went up to 4. And now since they went up by 1, cross off 4. And so then the host, after they do their operation, goes up by 1. So it's now the list looks like 1, 2, and then the host was up at 3, the list shrank, and the host went down by 1. So now the host is way up here. And so if the host is equal to the length of the list plus 2, so if it's 2 more than the list, then it knows that basically it's an odd operation. It like flips the end the odd way, or the even way, and so it needs to start at 2. Wait. Shoot. Sorry, I got distracted. Then it goes back at 2 and crosses that off because it will have just gone from 4. Then in this scenario, it just went boom, chop. Okay, chop. This one's good. Skip to this one and chop it. So this one stays alive because it skipped it. And so to check it, I did a bunch manually and made a little like spreadsheet just that showed a few manual answers. And I tried up to like 10 doing it manually. Oh, here it is. So like the top's like the number of people and then the winner. And then I could check it, and after I worked all that out, you can now put anything into the program. So let's run it. Let's test it with something we know. With 3 people, we know that it ends with the winner being number 3, according to this, the math we did earlier. So there are 3 teachers. It generates the teachers, then chops them off. I had it wait each time so I could see what was going on. But right now it's just for maximum speed, so it just chops them off really fast. So now let's go up to 7, ends with a successful, the like winner is number 7. And you can go through them manually and do that. So let's try with 7. And it chops them all off properly. So actually let's try it with, I tried it with 10 here, but for the sake of doing something different, let's do an 11 because I haven't tried this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, assuming I don't make human error, this should work. Good, bad, 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 good, bad, good, bad, good, bad, good, bad, good, bad. And so the winner should be 1, 2, 3, 4, 5, 6, 7. The winner should be number 7. So if we run 11, because that was the number of teachers we had here, into here, it generates the list, then chops it down to number 7. And you could do it with crazy numbers, like let's do 1,000. So there are 1,000 teachers in this room. So basically my phone's storage died, so I'm going to rerun the 1,000 program. Basically, I'm going to try it with 1,000 teachers, and it takes a while to, I didn't say hey Siri. And it's the generator program. Basically goes in, and this makes sure that there's no teacher 0 just by having that 1, so that it says like teacher 1 and teacher 2. I actually could put a space after that so it says like it has a space before the number, but it basically joins the text teacher and then their number, and the total number of teachers goes up as it generates, and then after that it's not really used for anything. And so now the host is going along, chopping every single other one, which is rapidly decreasing the length of this. This is as fast as the program can run. I'm using Scratch, which is like a block coding educational thing. So you saw it halved there, and then it got back to the top. And so now it's going to go through, it's going to get to around 250, and now it's going to go to roughly 125 before it halves again every time, and it goes faster and faster and faster and faster. And then, boom, 977. If there are 1,000 desks, the 977th desk is the one to win. So count the number of desks, run it through the program, and that's how you do it.